Hi everyone, this is Kieran Oversapian from Filmstorm, and today we're going to look at how to create generic movement using C# inside Unity. And this is actually going to be the start of a larger series where we're going to try and cover as much as we can about the basics of C# and all the little functions that you can use to build like a bigger game down the line. But hopefully by the end of the series you'll have a really good understanding of C# and will be really comfortable with creating pretty much anything you want. So to get started in this one, we're going to basically make a in-place capsule movement using C#. We're not going to use any animations because a lot of people have trouble with using root motion throughout the tutorials. So essentially by the end of this, we'll have a moving capsule in any direction. You're just using in-place motion without any animations, which you can actually go back later, replace the capsule with a player, and it will move really nicely because essentially you're not driving it with animation, you'll be driving it with just code. So let's get started. For the actual camera solution, the best thing on the market at the moment is the Cinemachine, and that's under Window Package Manager. And if we look up Cinemachine, you can see the latest version here is 2.3.3. And you just click this little install button and that will come compile and import everything. It doesn't take very long, it's already done. And then you can see that we have the Cinemachine dialog up here, and for a kind of like a GDA look around camera, we're going to create the free look. The free look automatically hooks up to the main camera tag and sets up the Cinemachine brain. So you can see when we move this, it automatically moves that main camera around. So let's rename this and just call it CM third person, because essentially that's what we want. And we need a player, so let's create a little capsule and let's bring him up. You can use this or you can use that. If you want to look from the side, you can click here, and you can also swing around so you can hit this X, and you can also hit this 2D, so that way you can really see where that ground plane is, and that looks pretty good. And I'm pretty sure it's 11, and that's it perfectly on that with the default capsule. Alright, so you can uncheck that and swing it back. It's really good for lining up stuff, and you can see this is ISO view. And you can click this again, and now we're in perspective. So that's how you switch between those. And let's also come in here and create the plane, and let's just scale that up. And we'll call this ground plane. Let's rename capsule to player. Yep, that's good. And we have pretty much everything under here. Let's create a new folder and call it materials. And let's make another one and just call this one temp, because this is going to be our temporary materials folder. And for now, we're just going to use the standard rendering pipeline, and in a future tutorial, we'll actually switch over to the high definition render pipeline, probably in the next or the one after tutorial. But we'll so we're not actually going to create that many materials for now. I just wanted to create this ground plane material so we can change this just to a darker color so we can kind of see what's happening better. So if we just drag that albedo down, you can see the ground plane a bit nicer, and that looks really cool. Alright, so we basically have a little scene set up. So one other good thing to do is let's go Command save, Control S, and you can go save as, and we want to save the scenes and just call this lesson 1, and we're going to call this generic movement. And you'll be able to download all of these resource files and scripts from filmstorm.net in our tutorials section. You can pretty much just look up this tutorial name for generic movement and it will pop up there. And you'll be able to do this for every lesson going forward. And we're going to have a dedicated server just set up so no files get lost while we're doing this. Okay, so we've got this camera that we've set up. We want to follow and look at the player. So let's grab the player and drag it in there, and you can see this Cinemachine camera automatically moves into this position. Let's just move it into a 16:9 ratio. And we can move the middle rig, so you can see we have these little circles, and that's kind of where it's rotating around. we actually want it to look maybe in the middle of our character. So we can change this to 0.5 for each of these. So that kind of makes it aim a bit higher. Let's make the radius a bit bigger, a little bit bigger, okay. And if we click play right now, you can see that we already have a pretty good little system. You'll notice that it's not very responsive, and that's because we can actually adjust these speeds. So we can adjust the max speed to maybe 4. And I think I want to uninvert. I think, yeah, we want to uninvert that one and invert this one. I don't know, it's just kind of a preference, but I think that makes it feel a lot nicer. Let's also increase the X speed maybe to 500. And maybe increase this speed to 6. Okay, we can adjust this down the line, so let's just remember these, or we can right mouse click on this, copy component, jump out, paste values, and that automatically places all those in here. And to adjust this kind of position, you can adjust this just to there, to 0.3. If you adjust this, this kind of simulates the game value of where the mouse is. So you can see in that left view, the camera going up and down. So if we say just 0.3, that's kind of in the middle. And that gives us a nice thing to start with. All right, so we have the player, and now we actually want to have some sort of input and see what happens when we actually press the buttons down. So if we go to Edit, Project Settings, and let's expand this guy, and we go to Input, you can see Axes. We've got horizontal and vertical, and it's already all pre-set up with W like for forward, S for down, A and D left and right. So you can use the arrow keys or WSAD. So we know that's horizontal and vertical. Perfect. So let's start to create a script now. Go to folder, and let's create scripts. And let's create a new C# script and call it movement controller. And you can see whenever a script compiles, there's a little spinning circle down the bottom right. Let's drag it over to our player and double click on it, which will boot up Visual Studio or mono-develop, depending on which one you have installed. Alrighty, so what we want to do first is just create a float, and you can make this private just so nothing else can access it. So private float, and we want input X, and you can actually put comma input Z. So you can actually create two floats back to back like that. And I think we also just want a private camera, and we'll just call it cam or camera, just to keep it simple. We'll probably just call it cam, otherwise there'll be some problem. Okay, and for here, we'll also probably want a private character controller, and we'll just use character controller to name the variable. And to start with, we can actually come into here, okay, and to automatically create a character controller on the script or whatever object the script is attached to. There's this fun class that you can add, which is require component, and you can say type of and character controller. And if we just save it now, duck back to Unity, you'll notice that if we remove this and then re-add movement controller, it will automatically pop up the character controller, because essentially that's what we want. And we can actually remove the capsule collider, and if you click play, it shouldn't fall anywhere, it should just stay there. Perfect. Okay, so now let's add some movement. So we actually need a reference to the character controller. So character controller is equal to get component, and the get component that we want is the character controller. So basically we're getting the component on the object, and the thing that we're getting is the character controller, and setting it to this new variable that we made up here. Perfect. And cam is just equal to camera dot main, just for our reference. Perfect. Okay, let's actually create just a new method and just call this movement manager. It's just going to be a void method, and input x is equal, which is that float, is equal to the horizontal. So we want to get the input dot stop changing input dot get axis, and we want to get the horizontal axis, and input z is equal to input dot get axis, and it's going to be we want the vertical. Cool. Okay, now we want to get the actual camera forward and right positions, so that way we can actually get the correct rotation. Since we already have the camera, we want to create a new variable. So if you don't know what you want to create, let's just write that, and we want to say forward, and we can actually change that to cam forward or just say forward, but since it's just inside this method, forward should be fine. And we want to say cam.transform.forward, and var forward, for var right, we want to get the right position. You want cam transform.right. You want to actually set the forward.y to 0, so that way it can't rotate anything weirdly. And we want to also set the right.y to 0 as well. We also want to normalize the forward, and we want to normalize the right as well. So essentially when you hover over it, it tells you what that should do. I think it just makes it between 0 and 1, so it keeps it in a nice number range for us. Okay, we also want to create a new variable up here, and it's going to be a vector3. So essentially it's just 3 floats together. That's what a vector 3 is. And we're just going to call this the desired move direction. For this one, we're going to say desired move direction is equal to forward times input z plus right times input x. We want to make the transform, so this object's rotation, equal to the quaternion, and we want to slope it. So it even says here it spherically interpolates between a and b by the time. So the parameter is clamped to the range of 0 and 1. So we'll sort that out here. And the first value will just be the transform rotation by the quaternion look rotation, and that says creates a rotation with the specified forward and upwards direction. So you want that. And for this, we actually want to make this the desired move direction. And this will be by, let's make a new private. Actually, this is going to be a new thing. It's going to be a serialize field. So this is actually going to show up in the inspector, and in serializing the field is the best way to display these kind of things. So let's go serialize field float, and let's just make rotation speed. So this is how quickly the rotation will be moving, and let's just make this like 0.3. We can adjust that later, and then just pop in the rotation speed. Done. Okay, now if we drive this movement manager, so in the update manager, so that way, or in the update method, so that way it calls this every frame. So if we jump back to Unity, let that compile, you'll also see that new rotation speed number pop up in here as 0.3. And you can see it's working very nicely, but as soon as we release the button, it will pop back to whichever way it was facing before. So we need a way to stop that from happening. So the best way to fix this is to create a new void, and let's just call it input decider. Okay, so this input decider, let's just grab this again. Or potentially we could always just cut this and pop it into the update method. So then we're not double accessing it, which will affect performance. Like, not very much, but it still affects it. So that way it's just in there and we can always grab those values as we need them. All right, so we need another private float. Let's actually pop it with this float up here. So let's just create, we can actually, since it's a private float as well, let's just call this one speed. You can just add another comma and that will add that onto that list that we've created. And we want to say speed is equal to a new vector 2 between this and the input z, so left, or the horizontal and vertical. And we just want to get the square magnitude of that. Perfect. And now we just need a decider to actually say, okay, well, if you're calling if we're pushing down, then we should also allow the player to rotate. So let's do that now. So if speed is greater than, and we need to decide a number, so we can actually create another serialized field here. So this should be something that the user can actually use. So the serialized field n is allow rotation, and if allow rotation is like maybe greater than 0.1. So if speed is greater than the allow rotation, then we should probably call the movement manager, so we can actually move that from the update method down. So cut it down into here. So we'll call that, and we'll now call instead the input decider, which will let this, it will actually call this, and it will check if we are moving, and if we are, then it's going to call this void. So we can actually probably just cut this and move this below this, so it kind of goes in order of kind of operation. Okay, so now if we jump back into Unity, okay, let's finish compiling, and just for our eyes to make it a bit easier, let's create a cube. You see a lot of people do this online, but it just helps figure out what way the eyes are facing. Perfect. So this is little goggles. We can even make it a bit wider, so that way we can just see which way he's looking. So if we press play now, and I look that way and I let go, he's not going to pop back, and we have a really nice rotation whichever way I'm push. So I'm pushing right, he looks right, I push left, forward, back, right, left, forward, and that way you can see that he has really nice rotations now. But now we just need to set up an actual movement. So how do we do that? Well, one simple way is, let's jump back. We can also, maybe in the movement manager, when we're pressing down, we're also moving him. But then if the player lets up, we actually want the player to keep moving a little bit. So we could always just create another one. So instead of maybe movement manager, we call this rotation manager. And let's rename this to rotation manager. And we also will want to create a new void. And maybe let's just call this the movement manager instead. So this is going to handle the movement, and that's the rotation. So let's call this movement manager. So whenever we're moving, or actually the movement manager should be moving before when we're pressing the speed. So let's add that under. Okay, perfect. So under here, let's create the movement script. All right, so if we say we want a new move vector, so we're gonna have to drive this. So we want a character, we want to get the character controller, this one up here that we get, and we want to say .move. And you see that it needs a vector 3, which essentially just tells it which way it wants to move. So we need to create a vector on which way we want to move. So let's just create a vector 3 and just say move direction. And this move direction is just equal to the this. So the first value will be x. So we want to say input x, which is our left and right. We want to say 0 for up and down, because we'll sort that out in the jump function later. And input z. And you can see it's saying, oh, what's going on? So we want to say new vector 3. And then if you put this move direction in here, you're going to notice something really funny will happen here. He's probably just going to go shooting off the screen, because essentially we're just feeding him a raw value. Okay, so that has finished compiling. So if we press play now, and as soon as I press right, he's gonna move like ridiculously quickly. And you can see he's also not moving in relation to where we're pressing. So we're gonna have to sort that out as well. So what if instead of doing this, we actually move him the same way that we're getting this desired move direction? So if we get this and we say move direction is equal to, let's just delete this and make it the desired move direction times time dot delta time. So essentially this will move it over a set number of frames. Let's see what happens. Let's click play. And voila, he's actually now moving in the direction that we push. So if we move this way, although you can see one problem is that he's actually moving super slowly. So how can we fix that? Well, let's come back to here. Let's create a new serialized field. Let's call a float. And let's just call this movement speed. And let's maybe make this 1. Again, since it's on the front end, we'll be able to change it while the game's running. And we want to say desired move direction is equal to time. And we'll put this in brackets. And we want to say movement speed times time dot delta time. And you can see if this is 1, essentially we're not doing anything to time, because if you have 1 times 1, it's 1. So if you make it like 1.2, he'll start to move a bit quicker. So if we jump back into the game now, and you can see we have movement speed here now, and we move, he's moving the same speed. But if we double, so we're timesing time by 2, it's very good. Although now you can see that he's being called every frame. So as soon as we let up the key, it's not letting it finish. And that is also because we are calling the rotation manager here. And if the speed is it's greater than the allowed rotation, which is 0.1, this will never actually get back to 0, because it will go back down, and as soon as it hits 0.1, it will go, and that's why he keeps moving. So if, let's just call else. So if the speed is greater than else, let's then set the desired move direction to vector 3.0. So that just zeroes everything out. But you'll also notice that it'll probably be quite jarring. He'll go to a direct stop instead of going back down. So this might not be the best way to handle this. Okay, if we make the movement speed a bit faster. Alright, it's actually not as jarring as I thought it would be. So that's good. That's actually a nice little solution. So there you go. We have a really nice movement system happening here. One problem that I saw before when we walked off here was there's no gravity. Okay, so what we want to do to create gravity, we're going to create a new serialized field, create a float, just call it gravity. Probably the best way to handle gravity, actually, instead of setting the value here, I'm just thinking about this, you can then come down to here and just say gravity is less than or equal. So this will just keep reducing the number, or make it equal to 9.8f times time dot delta time. So it's always going to try and lower this number to there. And we want to then get the vector 3 move direction again. and we want to then say is equal to, actually let's just make this, we can't redeclare it, so we just say move direction is then equal to the x, and then gravity, and then move direction dot z. Not sure if that will work. Let's just add if character controller dot is grounded, then gravity is equal to 0. Okay, let's finish compiling. Let's just make the movement speed permanently like 4. Gravity should just update itself. So we are grounded. Let's run over to this edge. And yeah, you can see we fell very quickly. So let's just make like a little ramp just to test our gravity. And run up here. And you can see that worked quite nicely. You could also slow down the gravity as well. If you wanted to make this not as fast, you could always just create another. You can make this one, let's just copy this. Actually no, let's just make this one called gravity, and then you can call this gravity multiplier. And then this one we will say, and then gravity is then equal to gravity times the gravity multiplier. Perfect. So you can see that if this number, if the gravity multiplier is 0, 0 times whatever it's timesing will automatically be 0 anyway, so theoretically this shouldn't even go down. Yeah. So if we want to adjust this, let's make it like that. You can see that the falling is much slower now. So if we make it like 0.4, so this way you can actually enhance the falling and make it feel a lot nicer. So that already feels a lot nicer. It feels a lot smoother for this. So I mean, if you want a fast-paced thing where the guy's falling a lot slower or faster, so if you make it like 2, this will actually times the falling by 2. So you can see it's super jarring. 1 will just be the default speed, so normal gravity. So if you make it like 0.85. Yeah, so that's all right. So I kind of liked it at 0.5. I think that was a good one. Yeah, so that feels nice. So there you go. We've created a really nice little like thing here. Character controller, very generic character controller. And this is probably the best way to get started with a third person. You can also adjust the camera to create like a top-down or orthographic view. You can see that this camera is actually a little bit close when we're looking down, so you can come back to this CM third person and go to the top rig and adjust the height, so that way when you look up you kind of have a nicer view of where we're looking. Perfect. So there we go, we've created a really nice movement thing without any animations, and the animations would be very easy to add in over the top just by using in-place animations. And then the next tutorial will cover sprinting and jumping. So that way if you hold the left sprint or left shift down or a bumper button on your controller or pushing the left stick, he'll start to sprint. Or if you press the space bar or like A or whichever button you want on the controller, he'll jump. So that's really nice. And then going on from that, we'll look at more complex things like coroutines, raycasts, and like creating trapdoors and stuff, and we'll start to really flesh out a really nice game. And then when we get to the end of the series, we'll also be exploring UI components and potentially even start to do like a little bit of Playmaker if people are interested by the time we get up to that. So hopefully this will interest a lot of people. And again, we're making the entire series available to download from filmstorm.net on our tutorial area. So from here on, you'll be able to access all of the stuff there as well. So thank you so much for watching. I hope you found this really interesting, and we're looking forward to completing more of these tutorials. But for now, stay tuned and click that little notification bell so that way you get notified about all of our tutorials, and we'll see you in the next video.